Our last section of this chapter is going to deal with the law of cosines. And if you remember from our discussion of the law of sines, there's a couple of instances where we just don't have enough information to use the law of sines. And those are the cases where we have all three sides and where we have a side, the included angle on the side. And the law of cosines is great for those. This section is also going to have another couple of formulas that are useful for finding things in a triangle, but they're a little bit different than the law of sines or the law of cosines. So the first thing we want to look at is this SSS case. If I have a triangle, let's just say it's a 4, 5, 6 triangle, and I'd like to know what the angles are. Every time there's a 4, 5, 6 triangle, the angles will always be the same. So if I call this A, B, C, then the law of cosines is going to look like this. It's going to say A squared equals B squared plus C squared minus 2 BC cosine of A. Now you'll also see the law of cosines written as B squared equals A squared plus C squared minus 2 AC cosine of B, where C squared equals A squared plus B squared minus 2 AB cosine of C. I think they're all about the same because it's just which angle are you calling A, B, or C. So we just might have to rotate things around. So although I write all three, I'm just going to end up really using one. This should look very familiar to you because it looks a lot like the Pythagorean theorem, right? C squared equals A squared plus B squared, but the 2AB cosine of C takes up for the case of, well, what if I don't have a right triangle? And so this works again for all triangles. So let's go ahead and put it into play to find the angles in triangle ABC here. So I'm going to erase this. And if I went here and say I wanted to find angle A first. So if I want angle A, I'm going to want to have cosine of A at the end here. So I'll say A squared equals B squared plus C squared minus 2 times B times C, times the cosine of angle A. So be careful with your order of operations here. 2 times 6 times 4 is going to give me 48. Now this is actually the place where people most often make a mistake because they want to just subtract this 52 minus 48. But you can't do that because that would be violating the order of operations. Instead, I need to subtract 52 from both sides and then divide by 48. Yeah, by negative 48, excuse me. So I'd have negative 27 equals negative 48 cosine A. So 27 over 48 is equal to the cosine of A. And then if I use my calculator, I can plug that in and do the inverse cosine of 27 over 48. And so I would get that A is approximately 55.771 degrees. So this is just one application, in this case, of the law of cosines. And that gave me one angle. Now you may say, how do I find the other angles? Well, I could keep applying the law of cosines, but at this point, to me, it's easier to do the law of sines. No matter what I do, it's just a shorter problem. Now, if I wanted to calculate a very precise definition or value for angle B and angle C, then I would go ahead and keep doing the law of cosines. But in this case, since I have a pretty good approximation, what I would do is I would say, if I wanted to find B, I'd say the sine of B over 6 equals the sine of that 55.771 over A. And so I would do cross multiply and divide, so 6 times 55.771 sine divided by, and then if I sorry, made a mistake here. So when I do the inverse sine there, the value I got for B is going to be approximately 82.818. And I could do the same thing for C, and it's always good to check at the end to make sure, am I doing this in the right way? Do all my angles and at the end add up to 180. So it's a nice check to do this. Just like with the law of sines, it's possible to get to the end and have sine of B or cosine equal to a value greater than 1. That's going to tell you that you have an illegal triangle, and either you didn't do the correct math or there's just some sort of mistake that you made. So that's an application of the law of cosines.